in the most simple sense, we build houses from the ground up. My name is Sam Kondratski, and I started Savick just a couple of years ago while I was still a student studying business. And I had the bright idea of taking straw from my family's wheat field and putting it into high-performance buildings. And so this originally was just an entrepreneurship project where I wanted to store as much carbon as we could in the built environment. And people are building their houses out of that. You can build a shop or a commercial building. We've got a lot of flexibility there. Chop straw insulation is pretty simple stuff. You grow the wheat, you grow the barley, and you take away the grain, but you're left with the straw, which dries in the sun, and then you're able to bale it up. And it comes here where we chop it. Unlike conventional straw bale construction, which is pretty exacting requirements for the density of the square bale, the length of the fiber, we're able to work with a much greater variety of straw and get the consistency required for construction. The straw is almost as fine as cellulose insulation, so we can actually use a standard insulation blower to install it into a floor, wall, or roof assembly. So the nice thing about a blow-in product is that you can take the insulation to the panel. So we're able to store about 2 houses will fit inside this tent. And then you can take that straw to the panel where it's getting fabricated in the shop. But Savick's shop is really simple. Material comes in through the back door, gets cut up at the cut station. We frame the panels on a framing table, and they get flipped and bundled and packaged right here. So we're able to really quickly scale up production and scale it back if the construction industry isn't perfectly predictable. This is a shop that's really dependent on human beings. We're having to work with people who have existing carpentry experience or train high schoolers to frame a really high quality panel. And that is way more interesting to me than to, have our design software perfectly feed instructions to a CNC machine. So what we're looking at here is a double stud wall that's insulated with chopped straw. And so with our assemblies, they're really easy to customize. So this wall, it insulates around an effective R38, but we can go as low as R20 to as high as R60. On the exterior, we've got our plywood nailers creating our rain screen on top of our Solitex Mento weather barrier. We have a thin wood fiber board and then a double stud frame that is insulated with dense pack chopped straw. We have 5/8 plywood that is air sealed with Tescon Vanna, and then our service cavity battens, followed by the interior finish. So we've experimented with a few different assemblies. We found that we can get more straw into the wall and have a simpler panel by going with this modified double stud. We're able to use either the exterior or interior as the structural frame. So it makes it really easy for us to do multiple story construction without having to rewrite the design handbook for incorporating those unique things. By and large, straw is an underutilized resource. Some people look at it as waste. So why not divert that waste into a useful function, such as housing? When you look at its qualities as a building material, it performs far better than a lot of alternatives. With the right density, not only does it insulate well, but it also performs really well with fire. With straw's hygroscopic properties, it creates a buffer in the assembly for slowing down condensation and mold growth concerns. So with a lot of natural building practices, it's really niche in that it has to be executed really well by someone with local craft. This is trying to take natural materials and put it in the context that's more accessible. So it's a simple assembly that's easy to get right, and then take, this material that we have literally in our backyard and use it and build some stuff that's close to us. Without high performance, construction principles, natural materials are going to have a hard time. I think it's really important that these assemblies are designed to last, in that they're going to be airtight. They're also going to be vapor open. And so while we can, design for things to be just so, the real world has all kinds of problems, and we want to be resilient to that. We want things to be able to dry out if they get wet. We want to be able to identify where the air leakage is after we've installed these panels. So when we walk away from a project, everyone's feeling really confident that this building envelope is going to perform as designed. It normally takes a couple days to stand up the panels for an average house. We often say that building panels is the fun part. Like when you're there with a crane, you make so much progress so quickly. It's really fun, and you'll have a crowd of people watching you. But the conversations with the local building authority, those engineering questions, it's not the status quo. There's always going to be unique things with every project. So one of the things that really excites me about working with natural materials is researching them, because there's been lots of different sporadic efforts to know more about things like straw and how to build a house out of it. But we're really trying to standardize that and put it all in one place. So we're open sourcing our research. People can look at our hydrothermal testing, they can look at fire testing, and hopefully come to the same conclusion as us, that this is a great way to build your house. I'm really happy with how such a simple material that is in my backyard performs so well. And combine that with an airtight, vapor open building envelope, and I think you'll have something that'll last for a very long time.